The energy transition is a pathway toward transforming the global energy sector from fossil-based to zero-carbon by the second half of this century. At its heart is the need to reduce energy-related CO2 emissions to limit climate change. Decarbonization of the energy sector requires urgent action on a global scale. While a global energy transition is underway, further action is needed to reduce carbon emissions and mitigate climate change. Renewable energy and energy efficiency measures can potentially achieve 90% of the required carbon reductions. The energy transition will be enabled by information technology, innovative technology, policy frameworks, and market instruments. The need for fossil fuels is increasing in line with the energy needs needed by humans every year. One of the energy sectors that uses quite a lot of fossil fuels is electrical energy. Power plants around the world generally use coal as their fuel. Apart from causing a bad impact on the environment, the availability of coal is also running low every year. According to projections from the International Energy Agency, IEA, by 2030 world energy demand will increase by 45% or an average increase of 1.6% per year. Most or about 80% of the world's energy needs are supplied from fossil fuels. Therefore, to reduce the use of fossils, an energy transition is carried out by utilizing renewable energy. Wind power, which is integrated with seawater desalination, which will generate electricity, can be a solution to the problem of fossil use in the world today. The utilization wind turbine can charge the battery and utilize the battery driving the small pumps to make the water enter after passing through the Y-type strainer. The airtight greenhouse is still. At the same time, wind turbine liquid heating will also convert the wind energy to heat the seawater, accelerate the evaporation of seawater. From that, we can accumulate the salt and mix with the seawater to increase the salt concentration. After that, we connect with the seawater with a high salt concentration pipe from the freshwater source, example river, with the membrane in the midst of both. Then we could accelerate the water products that could move the generator turbines that could produce the electricity. For implement this solution, we can estimate the cost defined in several parts, such as 1. Wind energy conversion system, $1,088 to $1,450 per kilowatts for an installed capacity of 600 kilowatts. 2. Water production for desalination process costs range between 0.9 and €1.65 per cubic meter. 3. Water conversion system, generator, $3,000. 4. Additional materials that estimated $1,400. Simply, the cost to implement this renewable energy is approximately more than $6,000. It can be concluded that wind-powered desalination can be competitive with other desalination systems while providing safety. It is therefore favorable to rely on renewable energies, specifically the wind due to its low cost and technological maturity, to power desalination systems. This process has a lot of good impact on our economy, social benefit, and environment. What can this process do for our economy? With the development of this system at several points in an area, electricity prices will automatically be more affordable. What can this process do for our social benefit? Society are easily obtaining and consuming electrical energy and drinking water, although in the remote area. What can this process do for our environmental conditions? Energy from desalination is able to reduce coal consumption, which is increasingly rare to be found recently, thereby minimizing the exploitation of natural resources. Some of the effects of global warming, e.g. melting icebergs, air pollution, and others, so that environmental conditions remain sustainable.